Hi, everybody. Thank you so much for joining us once again. It's been a couple of weeks. Please let us know where you're joining us from in the chat, wherever you're watching us on Zoom, LinkedIn, YouTube, Twitter, Twitch. We always like to hear where our global audience is joining us from. I am, of course, coming to you from beautiful, fragrant Soma in downtown San Francisco, California. Satya, where are you joining us from today?
From San Diego, California.
All right. And Erik, where are you joining us from this morning?
And I'm from Ljubljana, Slovenia.
Right on, right on. Yes, please let us know in the chat. Seeing India. Good morning, India. Good morning, Argentina. Toto, we'll get you your prize. Sorry about that. CVPR last week kind of put a stick in all of our spokes. It was as I said before the show started, last week was a long month.
Sorry, Toto.
Ireland. Oh, go ahead, Steve.
All right, so we have people from Belgium, Indonesia, Colombia, Ireland, Mexico, France, Ecuador. Oh, wow. Everybody is from a different country today.
It's impressive. Usually we just get India. No, it's wow, they're popping off on LinkedIn as well. Brazil, Pakistan, Los Angeles, Fort Wayne. Shout out to the Midwest. Yes, that is a cathode ray tube television behind me. Turkey, Pakistan, more India, Ottawa, Ontario, Canada, Nepal, Guatemala, Germany, Palestine, Louisville.
Oh, we'll just say United Nations now.
yeah, the delegates from Qatar. We got Uzbekistan, Egypt, or as I have a quick funny story. You know how sometimes you read a word but you don't know how it's pronounced, and you've read it a bunch and you just you get this head canon of like what it sounds like. This happens a lot, especially when we're young, I think, and you just have less experience like talking to people and hearing stuff. But an old friend of mine's dad thought Egypt was pronounced Egypt. It's one of my favorites.
That is funny.
Yeah, I mean, it's of course it's funny. Good morning, Pueblo, Colorado, Vienna, France.
All right.
We can go ahead and
we can get started.
Yeah, go for it, Satya.
Hello, everybody. Welcome to OpenCV Weekly Webinar. I'm Satya Malik, the CEO of OpenCV, and today we have with us Erik Kokalj, who is the Director of Applications Engineering at Luxonis. And as many of you know, Luxonis is the creator of OpenCV AI Kit. And today we are going to learn more about OpenCV AI Kit Series 2, which is the new iteration of the hardware, of the beloved OAK-D hardware. And before we get on the presentation, I also want to introduce Phil Nelson, who is the Director of Creative and Content at OpenCV. Phil produces this show, and if anything goes wrong, it's his fault.
That's right. It was me, Austin. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends on this show, can call me Phil. And I am here to remind you of a few things that we do every single episode of this show, the first of which is a special giveaway to you in the audience. Stay tuned. Later in the episode, our friends at Luxonis have generously decided that the winner of our trivia question today will get an OAK. So stay tuned for that later in the episode in about 45 minutes or so. We're also taking questions from you in the audience, and we'll do our best to provide the answers directly. If you stay tuned, use the Q&A button on the Zoom chat to ask your question there, or post your question in the comments section wherever you're watching, LinkedIn, Twitch, Twitter, Zoom, etc. But before we get started, Satya, would you like to tell us a little bit about the big launch we had at CVPR this past week?
Oh, yes. So we launched OpenCV University, and many people have taken our courses. What we decided is that, look, courses are great, but what we want from what our students were asking for is career guidance, right? So once people have taken some courses, some programs, first of all, at OpenCV University, we have created these paths so that people know exactly what they need to get a job in computer vision and AI. So basically, you take a series of courses based on where you are in your career and what kind of expertise you already have. Once you're done with that, we will provide you career guidance, right? But you have to complete some of our courses so that we will give you more assistance in how to crack a job interview, right? Because we realize that ultimately knowledge is great, but knowledge with a job is even better. So that's the goal of OpenCV University, to function as a place where people not only get their learning, but also career guidance. And also we are going to build out a community where people can collaborate. They can also talk to each other about projects, etc., about what jobs they have gotten, etc. So that's the gist of OpenCV University. We are not just about courses anymore. We want to grow beyond the courses and create a platform for people who are very serious about a career in AI.
Yeah, that's great. And again, thanks so much to everybody who stopped by the booth at CVPR last week. It was so awesome to put so many smiling faces to all of the names that pop up in the chat window here on Zoom and in our email inboxes, etc. If you stopped by, you saw some of the best swag we've ever had. These sweet carpenter pencils. We gave away about 300 of those at the show, about 1,000 stickers. 500 some handouts for OpenCV University and courses and etc. So thanks so much everybody for joining us at that awesome event, and a special thanks to our friends at Intel for the killer party that they let us be a part of on the second day there.
That's great. I also want to remind people that OpenCV.org is a nonprofit organization, and we are always looking for funding so that we can support the OpenCV library better. Our partnerships like OpenCV University, OpenCV AI Kit, OpenCV AI, which is the consulting arm, they all help us fund the library, but it's not enough, obviously, because the library is humongous and it takes a lot of time and effort and people to maintain the library. So we came up with this membership program. Large and small companies can join our membership program. It's basically a donation because OpenCV.org is a nonprofit. And if you can convince your bosses, your people in charge of making such decisions to support OpenCV, that would be great. The lowest level of membership currently is at $500 a month. And the company who sponsors this would have their logo on the OpenCV website, the main page, along with other sponsors. So you'd be surprised if you go to OpenCV.org, how few companies actually support the effort, whereas we all know that OpenCV is used by pretty much everybody. Anybody who does computer vision, they use the OpenCV library, but very few companies currently support the library actively. So please help us out. Okay. So with that, we are ready for the show. Erik, welcome to the show again. You have been here before, and I'd love to hear more about OAK Series 2. It's very exciting hardware development.
Yeah, thank you for having me.
Looks good.
Can you see the slides?
Yeah.
Oh, perfect. So today we're going to talk about the Series 2 of the OpenCV AI Kit, so OAK for short. So we can start at the beginning, so 2019, when we started the company. And first on the why, so why we formed the company and built the platform and our OAK cameras. So we wanted to address the issue of the bicycle safety, because in the EU alone, there are about 2,000 cyclist fatalities every year. And usually it's because the drivers aren't focused on the road. So for example, when they are texting and driving. And we wanted to create a smart camera that would detect the car trajectory and speed and warn the cyclists through the mobile app and car drivers through the strobe light if the car trajectory was on the hit course. And this warning could prevent many injuries and even save lives. And our founder, Brandon, created a prototype as seen on the bottom right of the images. So he used the real sense for depth perception needed for the speed estimation. He used the Raspberry Pi high quality camera for the vehicle detection, which was running on the Intel Neural Compute Stick 2. A Raspberry Pi was used to connect all the hardware together. And the final solution, well, it did work, but it was bulky, it was unpractical, and the system consumed about 10 watts of power. And the development was, of course, very slow because there was no easy integration between all these separate components. And we actually realized that we needed these 5 things from a platform. So a performant and embedded hardware solution that would be capable of performing spatial AI and CV pipelines workflows on the edge. And we realized that we aren't actually the only ones that are looking for such a platform, and that's why we built it. So as mentioned, the platform would need to be embedded, so a small size, low power, and low weight, and also have a fast boot to be performant. So high resolution, so we have up to 32 megapixel cameras, multiple cameras with high FPS and low latency. We needed spatial perception, so either stereo depth, active stereo, or time of flight. We needed to run the AI, so neural inferencing, either object detection, semantic segmentation, or recognition, and CV on the device itself, which contains the feature extraction, motion estimation, edge detection, optical flow, undistortion, and so on. And with our hardware engineering capabilities, with the platform that we've built, and together with the expertise of the OpenCV team, we've launched OpenCV AI Kit on the Kickstarter in 2022, which was a huge success. We raised over 1.3 million USD, and we shipped more than 8,000 open source spatial AI cameras. And on the bottom right, you can see the original OAK-D and OAK-1, the USB versions, and also the OAK-D PoE, so the power over Ethernet device as well on the left side.
See, we promised that version, which is on the left in the Kickstarter campaign, but we delivered the version which was on the right-hand side with the case and everything. So that's the beauty of the community. They trusted us to build this out.
Yeah, a bunch of developers don't really like to work just with the bare PCBAs. You can have short circuits, or you can quickly damage the device. That's why we realized that we needed the enclosure, and that's why we shipped the devices with the enclosure.
Especially after I burned out one of the OAK-D prototype units by accidentally plugging in the wrong barrel jack. Those things are dangerous, folks. Be careful.
Yeah, so I also did the same thing. But now those obviously those bugs are fixed. These were early prototypes. If you plugged in the wrong voltage one, it would just blow up.
Yeah, it turns out 12 volts is not what it wanted.
No, it's 5 volts, and that's why we also ship the adapter directly.
Yeah, definitely. This was also just, from a professional standpoint for me, this was the beginning of my journey becoming the voice of computer vision.
And let's quickly talk about the hardware and the computation, so the capabilities that are on the OpenCV AI Kit. So there we have an integrated Myriad-X GPU vision processing unit from Movidius, which has 1.4 TOPS of AI power, and you can run any AI model on the device itself. It has CV capabilities, video encoding, H.264, H.265, and JPEG. It runs stereo depth pipelines with filtering, post-processing, and RGB depth alignment. It can run the color camera up to 60 FPS. That's object tracking, and is also low power. And based on these hardware capabilities, we built the Depth AI library that abstracts this hardware to get the maximum performance out of all the accelerated blocks of the chip.
And so, once again, Erik, I just want to, for people who may not be familiar with, what these hardware specifications mean, just imagine, right? First of all, this is a camera. It's a spatial AI camera, which is capable of doing both depth estimation as well as running a neural network in real time. Both of them can happen at the same time. So which is fantastic on its own. But you also see these other things that a lot of platforms do not provide. You can do a lot of CV operations like image dewarping, warping, edge detection, feature tracking, etc., out of the box, right? And also image, video encoding, which you may not realize how important it is. Just imagine you have connected OAK-D or any other camera to a Raspberry Pi. And if the Raspberry Pi is doing the video encoding, it's not doing anything else. It's completely consumed, especially at 4K. I don't think Raspberry Pi can keep up with video encoding at 30 frames a second at 4K. So if all these things are done on the camera itself, the host computer or even Raspberry Pi that it is connected to, it is freed up to do other things. It can do other logic operations, etc. So all the heavy duty processing is done on the camera. And not only that, it has 2 cameras for depth estimation. It also has a color camera, right, which is for you can do inference on it. You can run a neural network on this color camera, but it's not required. You can actually run neural networks on these black and white stereo cameras also. If let's say you're working at night and you're going to flood fill the environment with IR light, then you can actually use the feed for one of the stereo feed to do object detection, etc. also. So very, very flexible arrangement, which allows you to do a lot of things, right? And the power is 5 watt, which is pretty reasonable.
Yep, that's completely correct. Thank you for the elaboration.
Yeah.
And you mentioned on the stereo depth from the stereo cameras. So let's actually check how this works. So the stereo depth that I mentioned. So on the top right corner, you can see the stereo camera pair. What it's doing is the approach is called disparity matching. So you find the feature on the left frame, and then you try to find the same feature on the right frame as well. And the distance between the same feature on the stereo pair frames, it's called the disparity, and it's measured in pixels. If you have the feature, so like an object close to the camera, the disparity will be high. And if you have it away from the camera, the disparity will be low, maybe only a few pixels. And the OpenCV AI library also provides the disparity matching algorithm called the stereo SGBM, which stands for semi-global block matching. And the code is on the left. So essentially, this algorithm, the disparity matching, is running directly on the OpenCV AI Kit on the accelerated hardware. So it's performant. It goes up to about 90 FPS. And on the bottom right video, there is another representation of this, so how it works. So for example, you have the features, so my eyes, the nose, and mouth. And you know the position of these features, both on the left and the right frames. And you can do the triangulation to get the depth in the 3D spatial locations of these features. And the red lines in the middle frame represent the disparity in this case.
And of course, the most important part of all this, import CV2.
Wouldn't forget. I mentioned the spatial AI a few times, so it's not our cameras aren't just AI cameras or just CV cameras. And what's so special about the spatial AI? So it allows the machines to perceive the world like humans can. So what objects are and where they are in the physical world. So normal AI cameras would just provide the 2D object detection. So where in the pixel space, so on the image, a landmark or an object is. While the spatial AI cameras provide 3D coordinates, so X, Y, and Z in meters in physical world where they are. And that's what is represented on the right side of the slide. And on the bottom left, we have another approach. It's called the stereo neural inference. So similar to what I showed on the previous slide, it's running AI both on the left and the right side. So for example, the landmark detection, and then it's doing the triangulation to get the spatial coordinates of the features. So for example, the eyes of the little robot. And now that we have a brief understanding of the hardware and the software and some approaches, we can present the actual applications, the AI vision tasks. And later we can see how we actually fuse these AI vision tasks together with the depth. So first we have the object detection, and on the OpenCV AI Kit, we actually provide on-device decoding for both YOLO model and OpenSSD model. And for the YOLO, we support all the different versions from the 3 to the 8, and we do the decoding on the device itself, which means that you can run the spatial object localization. So this means that not only it will take the color frame and run the inference on the device, it will also take the depth frame from the device. And with the bounding box, it will provide 3D coordinates, so X, Y, and Z, where in physical space an object is. So this is used to detect the objects in 3D location. But with that, you can also do what's the distance between the objects. So in this case, in the video, we have the in the COVID days, whether the person is too close to another person, you could send an alert. And with knowing where objects are through the time, you can also estimate the displacement over time, so the speed estimation. And similar to the object detection, we have landmark detection, and a few of these applications are the pose estimation, the hand tracking, and the facial landmarks. And together with the depth, you can get the 3D coordinates of these landmarks. So on the left video, you can, for example, develop an AI trainer that will count your reps, so how many squats and push-ups you did, and if the form was correct, because it knows where your joints are in 3D. Another AI vision task is recognition. So from here, you can run the face recognition, age and gender, or emotion recognition, OCR, which stands for object character recognition, so text recognition, person re-identification or vehicle re-identification, license plate recognition, and so on. So all of these tasks can be run on the OpenCV AI Kit. And another, which is quite popular, we have semantic segmentation, which is nowadays used a lot in the road segmentation of self-driving cars. And it's also used, for example, if you want the zoom virtual background or deblurring, or sorry, blurring, just like I have currently. It's running semantic segmentation to know for each pixel on the image, whether it's a person or the background. And then it does the blurring of just the background. And with semantic depth, you can perceive and navigate around the unknown objects. So for example, you can only get the depth and the point cloud of the road instead of the background itself. And then your self-driving car or robot can navigate only around those areas. And we can go now to the 2021, which is when we launch our second Kickstarter campaign, the OAK-D-Lite, together with the OpenCV team. We got all the learnings from the previous launches, and we incorporated it to make the new spatial AI camera that was the smallest, the lightest, and the most affordable up to date. And we shipped about 10,000 of these cameras in 2022. And the OAK-D-Lite has the same processing power. It has full depth AI ecosystem support, and it has the ease of use of the original OpenCV AI Kit.
And another
funny thing, recently we went to watch the Transformer 3D movie with the kids. So my older son, he said that I want to make a 3D, video. And we actually used OAK-D's black and white 2 stereo pair, and we recorded those videos. He actually wrote the code for recording those videos. And then, we initially we tried to do the red-blue glasses, but the filters were not good enough, so you would not see the depth properly. But we ended up, putting the side by side and then putting it on a mobile phone, and then using a viewer, a 3D viewer, to see this in 3D. So for people who are interested in those little applications, it's not a color camera; it's a black and white camera, the stereo pair, but still it's stunning to see, especially to show kids how stereo works. It's very informative.
And how
Because
easy
it's
it is
also
too.
That's cool.
aligned, the distance between the two cameras is very close to what a normal human eye is, right? And that was on purpose. And so when you, when you actually use the camera and record the video, you can just plug it in and it works beautifully. You can see everything in 3D.
Yep, exactly. And some of the applications that we found, because the OAK-D-Lite was very small and very lightweight spatial AI cameras, it was actually picked up by the drone community. And many applications were developed with it. It was used, for example, in localization applications, for follow me applications, safety landing, and so on. And to dive a bit more into this, so the CVPR from University of Madrid developed a solution on top of the OAK-D-Lite for the OpenCV AI competition. And it uses the stereo image pair to perform visual odometry. So that's on the bottom right. So visual odometry is the localization. So where in physical space the camera is and the drone as well, compared to the star. And since the OAK-D-Lite is also a spatial AI camera, they also mapped where objects are in physical space while the drone was moving around. And on the top right, there's an output from the OpenLander project, which was developed by Stefan. He trained a semantic segmentation model that finds a suitable place to do an emergency landing with the drone. So ideally, you wouldn't want for the drone to land in the middle of the road or on the roof, but rather on the grass fields. And on the bottom left, there's an application of the drone follow me by Richard. Drone knows where the person is in 3D, and it tries to be about 2 meters away from them all the time. And besides the object tracking that it does, one could also run, for example, a person re-identification model on the device. So the whole application would be more robust. And in case the tracker would lost the person, in between, it could still do the re-identification to find it.
That's awesome.
And finally, we have the OAK S2 in 2022. So this is our Series 2 offering. There are a bunch of different variations, as you can see, about 8 cameras initially. And they come in with a variety of different features. So for example, with wide field of view or normal field of view, with active or passive stereo, with or without the night vision, and also either for PoE or USB for both power and connectivity. And these devices are also smaller and lighter compared to our previous OpenCV AI kits. So first, let's check the wide field of view options.
Can I tell a little story before we go there on the 2022? So in the 2021 model, when we were running the Kickstarter campaign, as you can imagine, this was the middle of COVID, right? And we ran into, Luxonis ran into several issues with, people would not even get components for building these cameras. And
the global supply chain hurricane was the phrase.
Yeah, the global supply chain was really bad. And everybody, I know that most Kickstarter campaigns, they were delayed by 1 year. And Luxonis delivered it, I think, 3 or 4 months before the time. And the reason they could do that is that they had 6 different designs for the same camera, right? The components could be replaced and be by another similar, almost same component, right? So they had 6 different designs and they were able to pull it off. So, we delivered the OAK-D-Lites 3 months or 4 months before the actual promise date. So that was a little story about, how to manage supply chain and how clever the team is.
And hard working too.
Oh yeah, for sure. We actually bought the components before we even started the design, because those were the times that you really didn't know what you would be able to get in, for example, 2 months when you finish the design. So you had to do the procurement upfront and then start the hardware design based on the components that you actually could procure.
Oh
Yeah,
God.
we
Okay.
talked a lot about this back when it was happening, where there were, certain components, even simple things like capacitors, certain kinds of capacitors, where the lead time used to be 2 weeks for, say 1,000 quantity of 1,000, and that lead time went to 1 year. And it's so hard to make anything with those kinds of crazy constraints, but somehow the Luxonis team pulled through.
Yeah, I think for one component, it was also dimensioned like, oh, that component will be available in September. And we were like, oh, 1 month. Okay, that's cool. Oh, no, it's in 1 year and 1 month.
Right.
So it was a challenge, but we got through. Now it's looking better now.
Yeah.
Okay, so to the wide field of view. So we offer the OAK cameras with wide field of view as well as the normal field of view. And the diagonal FOV here is 150 degrees. And wide field of view is great for localization, as the cameras can find the descriptors which are used for localization afterwards. And cameras also do the on-device undistortion and the dewarping. And some customers also use 3 of these to get the full 360 perception. And on the bottom left, I actually saw this device on the ICRA conference in London last month by agilex.ai. So it has the 3 wide field of view cameras and also the LiDAR on top for teleoperation. So that was pretty cool to see.
That's great. Even our friends at FarmNG is a company that produces robots for agriculture, and they also chose OAK-D for obviously the this ruggedized version of OAK-D for their robot. And
well, they have like full size like tractors and stuff, like
yeah.
big ass. We're not talking about like these little, like this little robot here. We're talking like a full size John Deere.
Yeah. Yeah.
And then another variation is the Pro version. So what it actually is, the Pro version has integrated 2 things. So it has the IR illumination LED, which is used for night vision, and it also has IR dot projector, which is used for active stereo. And to get more into this, so what is active stereo? The issue with passive stereo is that when surfaces have no texture, are very problematic, because as mentioned before, stereo is used it's used based on the disparity matching. So matching one feature from the left to the right frame. But if there are no features, so for example, if there's a blank wall, you won't be able to do the disparity matching, and the depth output will be bad. So on the right side, we have both passive and active stereo comparisons of the white wall. And in case of the active stereo, you can see that the depth, it's a nice blue depth, which what you would expect from the wall. And for the passive stereo, there are a bunch of invalid pixels. And the random noise pattern that the projector projects in the IR you can see on the bottom left. And then it also, the Pro versions also have the night vision, the illumination LED, which allows you to run your AI and computer vision pipelines even in low light or no light environments. So you can also run object detection just on the black and white frames. And another option, in this simple example, we're running the stereo camera pair at 60 FPS, and every odd frame we have illumination LED turned on, which is seen on the left frame, and every even frame we have the dot projector turned on, or on the right frame. So we can generate accurate depth using active stereo at 30 FPS, and then we can also run our CV and AI algorithms such as feature tracking or matching for localization at 30 FPS as well in no light environments. So it's switching between the two very fast.
So the dot projector is synchronized with the camera shutter, right? These are okay. And also the LEDs can be turned on and off that fast at 30 frames a second?
Yeah, exactly. At 60.
Okay.
Yeah, every other frame.
Okay. Okay.
And we have full support for that in the library itself already.
That's very, very nice. Can I re-say this just in case some people who are not very familiar with or who are beginners may not have understood how big of a deal it is, right? So what's happening is that, let's say you are in complete darkness, right? There is no illumination. So you can turn on this. There are two things in the camera. One is the dot projector, which projects a dot pattern, right? And this is IR dot projector, right? So you cannot actually see it with naked eye, only this camera can see it. You also have an IR illumination, light bulb. It's almost like a IR light bulb inside it, which can illuminate the environment. It's not projecting dots, but it is just projecting it's just flooding the room with light. Now, there are two things we want to do. We want to do AI on it. We want to detect what objects are there in the scene. And the second thing is that we want to figure out what is the depth of the scene. At what depth are these objects located? Now, usually we use the RGB camera to detect where things are, and we use the depth cameras to detect how far things are. Now here, because RGB cameras are useless, RGB cameras do not respond to IR light. In fact, they have filters that cut out IR light. So to the RGB camera, the room is completely dark. But the stereo cameras, they do have, the stereo cameras are not meant for viewing. It is, it's okay. You will be able to see the output of the stereo camera, but they also respond to near IR, in the IR part of the spectrum. It also, the pixel values are also affected by it. That is why you can have this night vision where you put in the floodlight and the stereo cameras will be able to see. But now we want to do both of these things simultaneously. We want to detect where an object is, and also find the depth of that object. To do that, we on one frame, we flood it with IR illumination, right? The LED, and then this image everything becomes visible and you can do detection on it. And in the next frame, we turn off the illumination LED and just turn on the dot projector. The dot projector helps in accurately getting the depth, because it, as you can see on the right-hand side image, it texturizes the scene, right? It is putting a lot of dots in the scene, which makes it easy for stereo matching algorithms to perform. So now you can do both AI as well as depth estimation using these stereo cameras, right? And you're able to solve the problem even without the RGB camera. You're able to solve the problem in the dark, right? So it's a very nice feature, which, if not properly implemented, OAK-D implements it, but if not properly implemented, you cannot even do such sophisticated things.
Yeah, you need full control through both the cameras and the laser dot projector and illumination LED. And now we go to 2023. And in 2023, we launched the RAY, which is robotics access for everyone. It's a small desktop robot that was designed for development and education. So instead of spending hours or even days if you have a more complex setup, trying to add your OpenCV kit to your robot and try something out, you can just spend a few minutes to get up and running with your first robot app. And we will also provide some open source applications that will work out of the box. So, for example, 3D mapping, follow me mode, sentry mode, and a few others as well. So it has integrated OAK camera. So the same technology that powers the OpenCV AI kit is integrated into this small little robot as well. And it will also perform on-device VIO and sparse SLAM. So that's the localization and also the 3D mapping of the world around it. And it also has the integrated ARM that's running Linux, which allows all these applications to run on the robot itself.
Yeah, you can look back in the show archives way back on episode 81, about 7 months ago. We had a whole episode dedicated to Ray.
And here is a quick video. It's just running the pre-alpha video of the Ray moving around the office
Oh, they kissed. They're in love.
And another thing that we launched in 2023, which is actually together with the Ray, is the Robotic, which is the fleet cloud management solution. We currently offer remote monitoring and live streaming, app development and app deployment, which is easy to use, and also device analytics. And it's already available on the link provided there. And here is a quick demo of the Robotic. So you can log in, you can see all the connected devices that you have. So to get up and running, you just need to install the Robotic agent to your Linux computer. It should get installed in about 20 seconds. And once you install the agent, it connects directly to our server, which means that your camera, your robot, will be available through the portal itself. And when you have connected the robot, the camera, you can then deploy the detections and also see all the analytics of the platform. And you can also do the live stream.
As an old web developer, it warms my heart to see so many great web apps being built with this awesome physical technology.
So Ray is built on top of Keembay, right? It is a more advanced processor from Intel. Could you talk a little bit about it?
Yeah, sure. So the main benefit of the Keembay is that it has integrated quad-core ARM processor on the chip itself, which means it can run the Linux. And if you have the Linux, it's much easier development. We allow users to deploy custom applications on the device itself through our Robot Hub. And you can also, of course, SSH into the device itself as well.
Got it. So it means that when OpenCV AI Kit, you have to plug it into a host like a Raspberry Pi or a computer for it to work, right? So it's a camera that is smart. But this Keembay-based solutions, they have a built-in processor, and you can run Linux on it. So they can be completely independent, right? They don't need to be plugged into another computer. Is there a new version of OAK which will be based on Keembay?
Yeah, great question. We plan to have the Percept line. It's currently in our early release store, but because there were some issues with the chip itself and then Intel dropping support, we haven't pursued that further. And we are actually, I'm going to announce something at the end as well.
Okay.
With something new. And in 2023, we also launched the OAK-D long range and short range. So on the top right, you can see the OAK-D short range, which has 2 centimeter baseline distance, which is perfect for up to about 1 meter of depth perception. So for example, we can place robots, something like that. And on the bottom, we have the OAK-D long range, which has M12 swappable lenses. So and 15 centimeter baseline distance between the large baseline distance, and then the short baseline distance is 5 centimeters. So for example, if you want to have longer depth perception, you can swap the lenses to have a narrow field of view, which would then results in longer depth perception. And on the left side, you can see on the highway, the stereo depth perception that is able to get with the narrow field of view lenses. So up to about 100, 150 meters with very narrow field of view lenses and wide baseline distance between the stereo camera pair.
The short range one kind of looks like a lemur, like one of those Madagascar animals.
Yeah, I can see it. And something that we are currently launching as well is the OAK-D SR PoE. So the short range and the PoE version, which has the time of flight sensor. So besides the stereo, we found out that some customers, some applications require time of flight sensors instead. There are pros and cons both to the stereo and both to the time of flight depth perception. And here we actually have both. So you can see on the frame, we have the short baseline distance, 2 centimeter, and here we have the time of flight. And what we plan to do is to actually fuse together both of these depth maps to get the best of both worlds. So, for example, stereo issues are if you don't have texture, but for example, time of flight issues would be if you have a black surface, where black surface absorbs all the IR. Then with the time of flight projector, you can actually see anything. And yeah, there are some other things. So hopefully the fused together depth will provide great results to, for example, pick and place machines.
Is the demo on the right there, is that with fused depth or is that just with time of flight or just stereo?
Currently, it's just the time of flight.
Okay. The depth is really good on this. I was just noticing, you know, you can see like contours of the nose and eyes, like that's pretty solid.
Yeah.
Yeah. Usually
that's
time
because
of
of the
flight.
short range also.
Yeah, exactly. And there's another thing that we are currently launching. So about 3 weeks ago, we posted on our LinkedIn about a new camera type, the FFC. And this is actually the thermal sensing camera. So we haven't yet released the specs. So here they are. It's about QVGA, so about 250 by 190 resolution, quite wide field of view, long IR, temperature camera, which is quite accurate. And the applications that you can use it for is, for example, in night vision. So for night vision sensing, for example, for animals, people, vehicles, stuff like that. For
if you're hunting Bigfoot or other cryptids.
Yep. For machine and equipment monitoring, for example, in fire detection, fire safety, QA, quality assurance, and quality control of specific goods, and so on.
This is great news because we have been working with some LWIR cameras. The camera hardware itself is great, but the software these companies provide, these are horrible software. You cannot do anything with it. The basic APIs are so badly structured. It's great to see some cameras which would be affordable. First of all, these other cameras are also very expensive. And the software is just a nightmare to deal with. Something that you would think that, oh, I want to change the FPS. So there should be an API which says that, oh, change the FPS. And no, you have to send some bytecode around. All really horrible support for Linux.
Set the registers and stuff.
Yeah, exactly. That kind of stuff.
Yeah, like what year is it?
Yeah, and I got really badly bitten by this because I had a proposal for a client, and these things I thought that, just setting these things would be how many, a few hours, right? And it has taken us days to figure out each little bit, going through the documentation, specs, etc. And so we'll see. I'm very excited about this thermal sensing camera.
Famous last words of the engineer. How hard could it be?
I hear some. I see some comments on the chat. I'm not going to comment which camera company it is, but they are all the same, I would say.
Yeah, and of course we plan to nicely have the integration into our Depth AI library, which should provide all the ease of use. So for example, also combining the AI and the thermal results. So for example, do the AI on the color camera and then superimpose the thermal image on there to get, for example, the temperature of a face or of a person, which should be pretty straightforward.
Yep.
And the final announcement that we haven't yet announced from Luxonis is the Robotic Vision 4, which is the new chip that we are currently working on. And we are extremely excited about it. And we are currently building on top of the new chip that will power our next generation of spatial AI cameras. It
So
will have.
is this an exclusive announcement here to the episode of this show?
Yeah, it's the first announcement on the internet.
All right.
Awesome. Amazing.
And of course, yeah, we will provide more information about the new chip in the upcoming weeks on our socials. And as you can see, it has much more computational power and additional hardware accelerators. And yeah, some info can be seen on the side. And likely the roadmap will be that we get some early release products in the Q4 this year, and then Q1, Q2 next year, we'll officially release these devices. And as you can see, for example, the AI 48 or the 48x8 tops or 12 FP16 tops, which is much more compared to the original OpenCV AI Kit. It will also come with the octa-core ARM CPU, so you will be able to run quite a lot of stuff simultaneously on there. It will have the computer vision hardware accelerators for stereo depth, for the warp engine, optical flow, feature detection, descriptor detection and matching, and template matching. It will have quite an impressive ISP, so very high resolution, high frame rate with HDR and the image stabilizations on there, video encoding, and much more.
That looks solid. That looks awesome.
Yeah, that's a beefy feature set here. Really looking forward to hearing more.
Yeah, definitely. As mentioned, more information will be released over the next few weeks on our socials, so I guess LinkedIn, Twitter, stuff. And that is actually it from my presentation. So this is more for the future plans of Luxonis and the OpenCV AI Kit, besides the original one and the Series 2, and now the Series 4 and so on.
Awesome. Thanks so much.
That's great news.
Awesome presentation. And so if folks want to follow Luxonis and find out more about this Robotics Vision Core 4, where are the best places for them to follow you all?
I would say on our LinkedIn, so it's Luxonis, or on Twitter.
All right, excellent. Go ahead and unshare your screen there. All right, thanks, Erik. That was fantastic. I think now is a great time to do our giveaway. Erik, would you like to tell folks what they will win if they answer my trivia question correctly?
Yeah, so it's one of the OpenCV AI Kit Lite, so OAK-D-Lite.
Excellent, OAK-D-Lite. So if you need a reminder, or if this is just your first time joining us, we do a trivia giveaway on every episode of this show. Often it's for OpenCV courses or something offered by our guests, as in this case by our generous guest from Luxonis. I'm going to ask a trivia question that I've come up with based on the slides from the presentation, and your job is to answer that trivia question first in the Zoom chat. Now, if you have won in the last couple of months, please do not answer and give other people a chance to win. Also, if you answer before I'm finished asking the question, I will disqualify you. Do not test me. Don't test me.
No mind reading
I'll do
aloud.
it. No mind reading aloud. Get out of my head. Get out. So, during the presentation, we got a little short history lesson about OAK and OAK-D-Lite and so on. We learned a little bit about Ray. What year and month was the original OpenCV AI Kit Kickstarter campaign launched? What year and month was the original OpenCV AI Kit Kickstarter campaign launched? Folks are getting close. Right there. Not quite. Off by a couple of months, folks. Somebody's off by a whole year. May 1985. No, I believe that's when Doc. I believe that's when Doc Brown invented.
1984 would have been the right answer.
No, I think May 1985 is when Doc Brown invented time travel. So shout out for the Back to the Future reference there. Oh, they're so close. They're so close. Oh, right there. All right. I see Loreville Silva. Oh, no, that's incorrect. Subramanya Sheshadri. The answer we were looking for was July 2020. July 2020. Please send one email to phil@opencv.org and we will make sure that you get your prize of an OAK-D-Lite thanks to our generous guest from Luxonis. Now, I think we've got quite a few questions here. Mostly people were wondering.
Oh,
Yeah,
that's OAK-D-Lite that you're going to get.
Yep. It's a beaut, and it is very much light. I remember during the campaign for that, I was pushing hard for us to try to license the song Groove is in the Heart by D-Lite, but it was a little bit too expensive. Yes, so we've got a few questions here. Mostly people are interested in some of the stats and specifics on OAK-D series, the OAK Series 2 modules. We've got a lot of folks asking about different focal lengths and things like that. I have a question from me first. I know Luxonis has been doing some events, like we saw y'all at the Embedded Vision Summit last month. Are there any events that Luxonis is planning to go to in the next few months, or the rest of the year?
The ROSCON, definitely. Probably also IROS, and then that's it for this year, and then likely the CES next year in January.
Good old CES. I tell you what, I do not miss being in Las Vegas in January. People who know me know that I used to help design the booths for Occipital, another computer vision startup back in the day, for CES every year, and it was a whole lot of work right after New Year. So yes, a big quick shout out as well to ROSCON. ROSCON registration's open now. It's October 20 to 22nd, I think, or is it? No, October 18 to 20. And then PX4 Developer Summit is 20 to the 22nd in New Orleans, Louisiana. I am planning to be there. OpenCV may be doing something there as well, so stay tuned for that. We're actually pushing up against time here, so let's get a couple of quick questions. I know some people were asking about the early access stuff that Luxonis has been putting out. Would you like to talk a little bit about some of these the early access gear that's on the store right now?
Yeah, sure. So I actually have to check as well which devices are currently in early access, because we developed so many at the same time. Currently we have the long range, which I mentioned, the OAK-D, the short range PoE, which has the time of flight, is in the early access as well. The Ray, the small robot, the time of flight sensor, the FFC, and also some SOMs as well. So if you go to the shop.luxonis.com, on the top side, you have the early access, where you can see all the new and cool hardware that we are developing.
Fantastic. Yeah, and get that early access stuff. Be the first kid on your block to get the new stuff. Stefan DeWolf would like to know, can the segment anything model run on OAK Series 2?
So the OAK camera and the accelerator that's on there, it's about 1.4 tops, which is used more for the edge AI, which means that some models like object detection, like YOLO, Tiny, of course they will run at 30 FPS. For any kind of heavier models like Segment Anything, that would probably be way too heavy, because you would need a few NVIDIA GPUs to get it performantly.
Right. In fact, Segment Anything is not even used in the real world as is, right? The best use of Segment SAM model is to actually train another model. So for example, because it segments everything for you, it's very easy to then go and pick the right segments that you're interested in, right? That way you can collect data very quickly, but it is such a huge model that you will never use it for inference. It would be very expensive to use it for inference. So we have been using it internally, and the main use case is basically using it in conjunction, giving it to the data labelers who actually use it very efficiently to create a segmentation model. And then you can use DeepLab v3 or a smaller model like that to actually use in production.
Totally makes sense to me. Yeah, we're pushing up against time here. Erik, any last thoughts for the audience here?
Yeah, I guess you can subscribe to us on LinkedIn or Twitter for any kind of new notifications on the RVC4 and likely the Kickstarter in next year Q1 for the RVC4 based devices.
All right, you heard it here first, folks. Satya, you want to take us home?
Well, I also wanted to, the Luxonis Discord channel is also very, very useful for people who are starting out or who have any problems with the device. Many of the engineers are there and they reply, but the community also helps out. So that's another place to go.
Yeah, real active community there. Final thoughts, Dr. Malik.
Yeah, thank you so much, Eric. We are so glad you presented the path forward, and we are very excited about the next year's Kickstarter campaign as well. And so thank you so much. And thank you, Phil, for putting this show together. And as always, thanks our community for showing up. Sorry, we were away for 3 weeks because we were at CVPR, and then a few of our guests actually canceled. So, but we will be here. We are going to actually, moving forward, we are going to decrease the frequency of OpenCV weekly webinar, and we will basically wait until we have solid guests so that we don't want to do this every week. So the frequency will decrease, but maybe it would be a couple of times a month or so. We'll keep you informed, so that we don't run into this problem of canceling on the last moment. So that's a little announcement I wanted to make as well. And that's it. Thank you so much, everybody. We'll see you in a couple of weeks. We'll keep you informed.
Yeah, that's right, everybody. We have a very big announcement coming up later this week or early next week, so stay tuned for that. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be.
Thank you.
Thanks, everyone.